This is session 2 on the electrical system for the Airbus A320 family. Session 2 is entitled DC power. So we're going to go over first the generation, which will be the battery system. If you recall from the overview in session 1, our DC power supply is coming from the 2 batteries as well as 3 transformer rectifiers. Okay, so DC generation, and then we'll talk about the loads or the distribution. DC generation, there are 2 batteries. Those are going to be used for starting the APU, whether it's in flight or on the ground. You also have the supplying of AC and DC essential network in case there's an emergency situation where we have a loss of the supply coming from the IDGs, also from the APU driven generator, which is your auxiliary generator, or even your emergency generator if that backup is not there either. So then it reverts to the battery system, our DC power. Each of the batteries has 2 components associated with it. Hint, hint, this is a test question. Okay, so what 2 components are associated with the batteries? Okay, with each of them. It's going to be the battery charge limiter, and you also have a battery shunt. Okay, so those are the 2 components. The functions, what do they do? And then we'll talk about where they're located. Think about the battery charger limiter associated with the contactor, with the battery contactor. Because its main function, talking about the limiter, battery charge limiter's main function is to control the contactor. Because when you're doing that, you're affecting a lot of different things. So let me just kind of go over some of the things that the contactor affects, because either contact can be open or closed, which affects, the functionality as it continues. So in the electrical circuit. So a battery contactor is affected. It's going to ensure that there's battery charge. Number 2, you're going to make sure it's going to prevent the complete discharging of that battery if the aircraft happens to be parked. Also, it's going to protect the battery from thermal runaway or a short circuit. It's also going to control, it's going to be there to control equipment DC supply on ground when there's no regular power available. And it's also going to ensure the integrity of the hot bus. So you have that. Also, it's supplying equipment with the DC during any kind of transient fault conditions. So there's that, and of course, starting the APU is a big one. But that is what it's doing. That's its main function, is to control that contactor. Now, what about the battery shunt? The battery shunt, that is used to read charging currents, also discharging currents from the batteries. Okay, and just this one here, just to give you a few characteristics of it. It's weighing 300 grams. It's accuracy of 1% at 20 degrees Celsius in a roughly up to 400 amp range. Okay, and this is a test question, but where are you going to find the battery charge limiters? Okay, where are those going to be located? Okay, you're going to find those on the nose. Okay, those are going to be in the nose wheel, well box, nose wheel well box. And where are you going to find the battery shunts? Okay, where are those going to be located? Those are going to be forward of the 106 VU panel. Okay, so forward of the 106 VU panel. Okay, all right, so those are where you're going to find those. So remember, where are you going to find those things? So battery shunts, forward side of the 105 VU panel. So battery shunts, forward side of the 105 VU panel. And then the nose landing gear well box is where you're going to find the battery charge limiters. Okay. So those are 2 other components associated with the battery. Okay, or the batteries. And you also have some other components involved with this battery system. And that's going to be your, you've got fuses, you also have switches, you've got, other contactors, but, mainly you've got that. Now, what about the batteries themselves? Those are located on the floor of the left-hand forward avionics compartment. So that's where you'll find the batteries. Okay. So, and then again, when we're looking at the switches, remember that we have switches involved, are obviously going to be in the cockpit. So we have BAT 1 and 2 push button switches, which are on the 35 VU. Okay, so remember with the emergency, we'll get into session 3, we're going to talk about emergency, the emergency system, power system, electrical power system. But here, remember I said that 35 VU is your regular electrical control panel, but then you have 21 VU, which is your emergency electrical power panel. Okay, so what about the fuses? You know, and their holders. Where are you going to find those battery fuses? Those are going to be located behind the lower half of the 124 VU panel. And that's behind the co-pilot seat. And the cockpit aft wall behind the co-pilot seat is where you can find both of the, for battery 1 and 2, you'll find the fuses and the holders there. All right, now some line contactors, those are going to be located on the 105 VU panel. Okay, 105 VU panel. That's where you'll find those. Okay. And just kind of a note on voltage, your battery, and it may vary just a little bit, but battery voltage is roughly about 25 volts. So if it goes below that, that's considered, you know, the charge is too low. Okay, so, all right, so kind of a little bit on the functions, you know, battery system functions. In relation to the contacts, let's say we're going to talk about that. So on contactors, when you have battery contactors, they're either going to be opened or closed by some condition. So if you have a transient fault condition, then the battery contactors are going to close. Okay, but then if you have the battery voltage to be lower, remember I said, than a certain number, just say roughly 25 volts at the beginning of a charge cycle, then the battery contactor is going to close after a short delay. Okay, and that's this, you're going to see this again. Okay, it's on a test. Also, what about the current? So we got voltage and current. So if we have the battery charge current that's lower than 4 amps, you know, estimated 4 amps, at the end of that charging cycle. Okay, first one is at the beginning. So we're looking at voltage at the beginning of the cycle, and then we're looking at the current at the end of the charging cycle. So in one instance, when we talk about volts at the beginning, if those volts are not enough, there's too low voltage, those contactors are going to close. If you have too low a current at the end of that cycle, the contactor is going to open after a short time. Okay, so in one instance, the contactor is going to close. In the other instance, the contactor is going to open. Okay. All right. So, and you know, all of the circuitry here is also to prevent thermal runaway, which is a possibility. Thermal runaway is kind of a self-feeding cycle of increasing temperature, with just that whole chemical reaction that's going on with whatever's causing that increase. So it's a dangerous condition to have, you know, with increasing, you know, constantly increasing temperatures. It feeds into that. So that you have an battery isolation in case there's an increase significantly, you know, based on certain, you know, levels. And of course, starting the APU, when that happens, both the batteries are going to be connected to a 28 volt DC battery bus, you know, to start that the motor for the APU. If the plane's on the ground, and you don't, you know, there's not the IDG APU or external power that's available there, you know, the DC batteries can be used. Okay, and they are used. The danger of having the battery not being charged, you know, up to where it needs to be, if there's something that's draining it, then that's unnecessarily draining that, then it's going to be cut off from that DC network. Okay, the only time it's not going to be, when that happens, when it's cut off from the DC network, the one thing that it won't be disconnected from is its own hot bus. So be aware of that. You're going to see that. So it may be disconnected from the DC network, but it will not be disconnected from its home, you know, from its related hot bus. All right, so continuing on with some functions, because remember we're talking about emergency configuration where, involving the DC power to provide power supply to a DC AC network. So what about RAT and emergen control? So let's say we have a loss of, a function of the AC normal bus bars. Okay, we don't have that going on. So what's going to happen? We're going to go to an emergency. Okay, so 21 VU is going to show on the panel some kind of indication of now it's in a RAT and emergen position. Here you've got the red fault legend of that switch, and on that emergency panel, which is 21 VU. Okay, now be aware, sometimes it depends on the aircraft variant, okay, not just the model but the variant of it, that you may or may not have a red legend. And the reason why is because the mechanism on some of those variants of aircraft are the way that the programming is that if you have an extension of the landing gear, or whether it's extended or it's compressed, you may not have that fault legend, actually show. So just kind of be aware of that, depending on which one you're working on, which aircraft. Also, we have the APU start sequence, right? That would normally be, when we have that going on, when it starts, normally we would have a DC power kicking in to get that starter motor going. But, let's say that we have in-flight an emergency situation, then that APU start sequence is going to be inhibited for a little bit. Okay, it could be for several seconds. That could maybe be a little bit different from one plane to another, but roughly let's just say around 40 or 45 seconds. Some kind of, moment there it'll be inhibited. Okay, so you also have the BAT fault warning control. Okay. Okay, so it gives you an idea there. You do have on the MCDU menus, you have the battery charge limiter MCDU menu. Some of the indications that you're going to find on here is going to be the bite test. You have the power up test. We've been mentioning about power up test for a while now. So we have power up test. You've got communication with the MCDU and or the ECAM. And then of course monitoring of the BCL, your battery charge limiter system, is going to be here with the peripheral circuits. Okay, and those peripheral circuits are monitored through obviously the inputs, that we have from different places. So bite, your bite obviously is going to allow for testing on the ground, and then tests on the ground from the CFDS. So at each power and also from the CFDS. And just knowing that you have your class 3 failures that can be read using the CFDS. You can localize those failures by means of those readouts. So that's coming from that right there. And just to kind of give you an idea, the BCL, it will say BCL 1, whether it's BCL 1 or BCL 2, depending on which battery. But you can see your last leg report. Obviously your class 3 faults test, or which test. Your system report. So you have a system report test for different things. Your air conditioning, AFS, your comm, electrical, fire protection, etc. Nav, ice and rain, things like that will show up on there. You'll also see for system report for both the BCLs, your GCU emergency, your AC gen, okay, and also your 3 transformer rectifiers. So what about fuses? I know I mentioned earlier about the fuses and where they're located. Remember behind this co-pilot seat? There you have spare fuses that are obviously of different amperage that are located in the cockpit. Okay, in case you need to replace those, those fuses. This would be for battery 1 and 2, your DC essential or DC normal bus switching fuses. So those you can find, there. Spare fuses also, there's some, again, behind the pilot seat. So besides co-pilots, you have one behind the pilot seat. Those can be used as a replacement for some of those normal bus switching fuses. And again, just be aware, same thing with, you know, the fuses that are available there for, you know, convenience, you know, for maintenance. It depends on which variant of aircraft that you're on as to which fuses are there, you know, for which ones that you can repair or replace. So just be aware of that. Refueling on the battery. This is refueling the aircraft. Okay, and there's going to be a test question related to this one. You have, the way this is, there's a refueling door on the right side of the fuselage. So on the right side of the fuselage, near the wing. Okay, I think it's below the wing. So there, if the plane needs to be refueled, and that's what's happening, that refuel door will be open. Okay, but there's a certain time limit on how long the refuel door is open, before the battery discharges. So just be aware, it's just, you want to keep the refuel door closed if you're not, if the refueling is not going on the aircraft. If you're refueling the aircraft, then obviously, the door has to be open. But if you're done, close the door. That's the recommendation, because it's not gonna, it's not a good idea if you don't need to have it open. Okay, so it kind of gives you an idea with the refueling off, on the battery, and the fuses, the switches, the contactors, the two components that are associated with the batteries, with each of the batteries, your battery charge limiter as well as your battery shunt. Okay, and locations of where those are where you can find them, and also what kind of things you can find on the display on the the BCL the MCDU menu as it relates to the BCL. Okay, so that's what you have for your generation. So now let's kind of go over, talking about the distribution. So these are your loads. Now we're talking about main bus bars for DC power. There's also sub bus bars. So you have your main bus bars, and then from there can be distributed to sub bus bars. So with here on distribution, the distribution is going to come from the transformer rectifiers that are going to the DC bus bars, okay, located in the electrical power center for DC. And then from there, like I said, they can get signals or get instruction electrically to be distributed to the sub bus bars. And then from there, obviously going to the user components, user systems. You have the main one, which is standard across, depending on the size of the aircraft, because typically it's going to be a 28 volt DC distribution network, but there may be a little bit different configuration when you get in some others, but that is standard, is 28 volt DC. You have those going to certain bus bars, and you can refer to your AMM to know which bus bars. Remember the coding that I mentioned before? If you see a PP, that's going to be referring to your DC network bus bars. If it's an XP, that is all in the category of your AC power or AC network, power network. Okay, so PP is going to be your DC, XP is going to be referring to your AC. It's just the best way to remember it, or just to do quick, because then you got numbers identifying, whether it's left or right, which is it, for. So that's what we have here. It's just going to those buses that are the PP buses, because they're DC buses. Okay. You have your main distribution, of course, and you also have your essential distribution. Those are connected to your essential, obviously your essential buses. Okay, and also your shed essential buses. Those are the first to go, and there's an emergency, and there needs to be a really good use of the electrical power that's remaining in that situation. Okay, so you have this 28 volt DC distribution network that's corresponding to the bus bars, and of course also to your sub bus bars. And it's going to, the circuits are going to control all of that. Okay, so you have your normal flight configuration. You also have automatic transfer of some of the electrical power in case there's, fault conditions. And of course, you're having an indication on the ECAM page, on your page on the ECAM. That'll be on your lower display. And then remember I said you got the 3 transformer rectifiers. So you have DC power coming from there that are going to the bus bars. There's certain bus bars that are going to, I'm not going to name them because it could change. It could be different for the particular specific aircraft that you're doing maintenance on. So just know that the transformer rectifiers are supplying but certain DC bus bars. Okay, and those are going to be supplied whether it's in flight or on the ground. Okay, and then of course you have bus switching contactor control. It's normal bus switching. Your loads, just continuing on with all of this. Let's just say that we lose the function of one of the transformer rectifiers. Okay, then you're going to have bus 1 and you're going to have a battery bus that are going to be restored from the other transformer rectifier through switching. It's kind of like train tracks, but being able to have a bus 2 switching contactor so that it can still, handle the supply that the TR1 was doing. So that's just conceptually what it's doing. So you do have a recovery that's basically making up for what it was doing. Of course, if you have both of them, get lost, then you're going to have the essential and the shed essential buses that are restored from the essential transformer rectifier, because there's a transformer rectifier that's called the essential transformer rectifier, and that's going to restore, the loss of the TR1 and TR2 functions. When that happens, of course, you're going to have a warning that's going to come up on the ECAM, and it's going to be a warning on on there on the upper, and at the same time you're going to have one on the lower. So when you have both, and say both of those, like I'm talking about TR1 and 2, both of those are not working, then you're going to have the essential TR begin to supply what TR1 and TR2 was supplying. Okay, just a little bit more on the transformer rectifiers. These are gonna, they're controlling internal logic through a contactor, right? Just makes sense. And it has its own protective functions, within it. They're also ventilated by air that's extracted from the ventilation network. Because remember what I said earlier when talking about the cooling system, the TRs are located in the avionics compartment. They're needing to be cooled. So there's just extra air there that's extracted so that it can, make sure that it's cooled enough. Okay, and just kind of the TR characteristics that you have as far as output voltage, it's running again around the 28 volt mark, but you're going to have variations about maybe a couple of volts when you have no load. If you do have a load, then it may be a little bit lower voltage at 200 amps. Okay, and as far as interchangeability, I've mentioned about interchangeability before in other Gen FAMs, but definitely follow the AMM as to what is interchangeable and what is not. The TR1 is fully interchangeable with the essential TR. Okay, so I'm not saying that TR1 is interchangeable with TR2, though it may be, but I'm just saying that be very, very careful. Pay attention to the unique identifiers of the parts that are replacing. Okay, what you need to replace. because they may look exactly alike, and a lot of the times they look exactly alike. You cannot tell the difference other than the unique identifier or part number, you know, associated with that and what you're trying to change out. So please be very, very careful, because the TR1 should be interchangeable with the essential TR, but the TR1, it's not going to be interchangeable with TR2. They have different electrical compositions, you know, as far as their engineering. So that's why I say that. Just be very careful with that. Okay, so here, you know, when do they kick in? We know we have AC power as our normal configuration as far as electrical power of the aircraft. That's going to be running until something goes wrong. Then if you lose one of those AC power supply, you know, one of those sources, then you're going to have, you know, some of the TR1's going to, besides your generators, I'm talking about past your APU driven generator, and of course you got your emergency generator that's run by that hydraulic motor generator. You have the transformer rectifiers that are going to start to, you know, to operate and kick in. So, you know, of course they each have their own DC bus bar. Okay, TR1 has its own bus bar that's supplying it. Okay, and you know, same thing with TR2. The essential transformer rectifier. Okay, that one is normally supplied by the CSMG. Okay, your constant speed motor generator, or it could be normal buses, you know, whatever is available there. Okay, so let's just say we have bus 1, you know, we have bus 1 being supplied. Then we're going to have a TR1 output that's delivered to the DC bus 1. Right, we always have the contactors as kind of the carrier in between. Be nice to have this, you know, to show this on a board or on a slide. But anyway, bottom line is that you've got that contactor to make that connection. So then you have the energizing of that. Okay, when you don't have the TR protection active. Okay, and of course if there's an abnormal configuration of the TR1, all that information is going to be sent to the CFDIU. Okay, it's going to be sent to the ECAM system and also to the switching system. Okay, the normal DC normal generation switching system. And of course we have the same situation besides TR1. You know, we have the same operation with TR2. Okay, that's pretty much the same. As far as resetting, because you know there's manual resets, there's auto resets. With here, if there is a fault that exists, then that TR is out of commission. Okay, you're gonna have to, or what's gonna have to happen is have a reset in order to have that TR back in operation. Okay, and so there's a toggle switch in the avionics bay that can reset that to make that active again. But that's going to be either from the MICDU through the CFDIU, you know, or you can do it like I mentioned about the toggle switch in the avionics bay. Either way is a way to reset the TR. All right. Okay, so as far as, you know, the location is very important. But I mean, obviously in the avionics compartment, but in particular where? Okay, these TRs are located on the right hand forward avionics compartment. Okay, those are where you'll find both of those. So it's the forward avionics compartment. You can see that on a diagram. It's on the right side forward part. They each have their own shelf. Okay. If you go into the cockpit, we're going to find the contactors. So your TRs are located in the avionics compartment, and the contactors for those are going to be located in the cockpit. Okay, and those are, and specifically in the cockpit, you've got, I mentioned before, those contactors. Remember I said the lower half of the 124 VU panel, and then the other one, actually, the contactor for the TR2 is located on the 123 VU. So one's at 124 VU, the TR2's contactor is located on the 123 VU panel. Okay, so right side was TR1 and 2, and then now what about the essential TR and also its contactor? Then we have that on the left side, okay, left hand avionics compartment. So right side is your regular TR1 and 2, and then your essential TR is on the left side. Okay, that's the forward left side of the compartment. Okay, I know I mentioned about resets. So we're doing bite and maintenance tests on the transformer rectifiers. We're going to be doing that from the CFDS. Okay, so you've got there, of course, your MICDO. I mentioned that before, your MICDO. Remember, so you can also, reset. You can do a reset from the MICDO. You also have the CFDIU. Okay, so the TRs are connected to the CFDIU through the links. One of them is used to send a ground signal to the CFDIU in case there's a fault, and then you have the other one used for a reset. Okay, so remember I mentioned on the MICDO. On here, on this reset procedure, the first thing is there's a system report test item on there. So you're gonna do, that's what you're gonna use. So with that one, you're gonna select, the whichever, like TR1 or 2 or 3 on the elect menu. And then when you reset it, if it works, if it resets successfully, then there's not going to be a fault that shows up on the MICDO. Okay. Of course, if there is a fault, then there's going to be something showing up on there. Okay, so now we got, you can also do a manual reset. There's a reset of the TR protection. So if, let's say that the CFDIU is not available, you can start a manual, and that's on 103 VU panel. There's a switch there. The identification of that push button switch is actually a TR RST for transformer rectifier reset. So TR RST, when you see that on the 103 VU, that can be done as well. All right, so of course, then you have switching, your generation switching. With here, you got DC shed essential bus contactor. Both those. You can access those through the certain avionics door, and that's all. Those two are located on the 106 VU. Okay, 106 VU panel. Okay, and of course you have some of the other fuses, I'm talking about fuses for the essential buses. Those are going to be on the 105 VU. Okay, so it gives you an idea with the DC power, the DC power components, subcomponents, some components that are associated with the main, which would be the batteries, but you also have those 3 transformer rectifiers. So that's it right there. The 2 batteries and the 3 transformer rectifiers with its own contacts, the fuses, the switches, in order to provide the AC/DC network of electrical power in the case of an emergency. Okay. All right, so let's go over some knowledge checks here, and then we'll finish out with session 3, just talking a little bit more about emergency power. Kind of goes along with the DC in one respect, because DC power is not used other than on the ground if there's not any other power source available, or if you're, say, starting the APU getting that going. But as far as, an emergency situation where you don't have that AC power going, DC power is certainly used, right? Okay, so let's go ahead and do some knowledge checks. First question. The sources of DC power are the batteries and the transformer rectifiers. Is that true or false? Yeah, that's true. That's what we've been talking about all this time. Okay, what is the main function of the battery charge limiters? Option A, is it to control the battery contactor or to prevent the battery from being overcharged and to help restart the APU? Okay, just remember, just a little tip, if there's one part of an answer that's wrong, even though the other part might be right, the whole thing is wrong. Okay, the answer here is the first option. Controls its main function is to control that battery contactor. Okay, in the event of failure of both TR1 and TR2, the essential TR gets supplied by which components? Okay, option A, the CSMG or the AC normal buses, or option B, the APU generator. Okay, it's going to be the first option. Okay, the TRs are located, option A, in the aft avionics compartment or in the forward avionics compartment. Okay, it's option B, that's where they're located, in the forward. Okay, the two batteries are associated with two components. What are they? Okay, option A, battery shunt and battery charge limiter, or option B, battery recharger and battery monitor. Option A, right? What can the technician find on the 105 VU panel as it relates to the DC system? Option A, fuses, or option B, contactors. All right, the answer is B. Okay, on 105 VU panel, you'll find the contactors. What can you find on top of the nose landing gear well box related to the DC generation system? Okay, option A, battery shunts, or option B, battery charge limiters. Okay, it's B. That's where you'll find the charge limiters. What can you find behind the lower half of the 124 VU panel as it relates to the DC system? Okay, fuses or switches? It can be fuses, that's where you're going to find your fuses. Okay, where are the battery shunts located? The nose landing gear well box or the forward side of the 105 VU panel? Okay, that's going to be the forward side of the 105 VU panel, right? All right, to prevent complete discharge of the batteries. Okay, we're trying to prevent the complete discharge of the batteries. The batteries are automatically disconnected from the DC network of the aircraft. Is that true or false? Okay, that is true. What information can you possibly find on the MIC-2 menus for the BCLs? Okay, option A, last leg report in class 3 faults, or option B, current leg report in class 1 faults. Okay, the answer is the first question. Okay, where are the spare fuses located? Okay, in a bulk locker behind the first officer's seat, or in a bulk locker behind the captain's seat? Okay, we have them actually both. There's this one you find them behind the captain's seat. Okay, where's the refuel door for refueling the aircraft? Okay, where is that, on the fuselage below the right wing or on the fuselage above the left wing? All right, it's answer A. Remember I said it's on the right side of the fuselage, and that's actually below the right wing. What is recommended when refueling is done on some aircraft, I should say? Okay, close the refuel door or keep the refuel door open. Okay, it's the first thing. If you're done, the refueling's done, close the door. Okay, Okay, what is the function of the battery shunt? Okay, option A, to give a stable support platform base for the batteries, or to monitor charging and discharging currents of the batteries. All right, the answer is the last answer, right? As a result of control of the battery contactor, thermal runaway or short circuit is prevented. Is that true or false? Okay, it's true. All right, regarding battery system functions, when the battery voltage is below about 20 volts, what happens after a short delay? Option A, battery contactor opens, or B, battery contactor closes. Which is it? Okay, the answer is B, and the second answer. Battery contactor closes. Okay, regarding the battery system functions, when the battery charging current is lower than 4 amps, what happens after a short delay? Does the battery contactor open or close? Okay, remember I said about current. Okay, battery contactor closes. Okay, regarding the battery system functions, when transient fault conditions exist, are the battery contactors open or closed for several seconds? Okay, so battery contactors are closed or open? Okay, they're closed for several seconds. Okay, when the aircraft is on the ground and the battery charge is low, the battery is automatically disconnected from the DC network, but is still connected to its hot bus. Is that true or false? Okay, that's true. Okay, that gives you an idea on some of those. Gives you an idea on some of the information, some of the information that you want to have and know. All right, so we're going to go ahead and close this up, and then we have one more session. We'll talk a little bit on emergency, and then we'll have some knowledge checks there.